Hello, my name is Chris Tucker, Applications Engineer in MCUA Group here at Microchip. Today we will be demonstrating the BodyComm technology by using the BodyComm Development Kit. The BodyComm technology is a bidirectional communication method which uses the human body as a medium between two devices. The BodyComm Development Kit comes with a development board along with two mobile devices stored within key fob cases, each with a different valid mobile ID for use with the kit. The development board is preloaded with demonstration firmware which uses multiple methods of initiating a scan, along with multiple debug states helpful when developing with the BodyComm technology. The demonstration firmware uses a challenge and response protocol example. In the first method, we can see a coupling pad located on the development board. This coupling pad acts as a touch sensor and as a signal coupling location. This means that when I have one of the mobile devices in my possession and I rest my hand on the coupling pad, then communication between the board and the mobile is established. If we look at the mobile device within the key fob, we can see a red indicator light blink as it transmits its response back to the board. If I set the mobile device down and then again rest my hand on the coupling pad, we can see that although the board is indicating it is searching, it cannot find a valid mobile device near my body. Yet if I pick up the mobile device and let's say this time put it in my pocket, now when I rest my hand on the coupling pad, we can see that it again finds a valid mobile device in my possession. Here we demonstrate the BodyComm technology by coupling a signal from the pad to my body and then from my body into the mobile device within the key fob. For the development kit's application, the mobile is in a sleep state until being challenged by the board. The mobile will then generate its response and then return to sleep. In the second method, we are able to initiate a scan by a simple push button. Then, by bringing the mobile within proximity of the signal coupling location, in our case still the coupling pad, we can again see communication established. The demonstration program also supplies multiple debug states helpful when using the BodyComm technology. The development board is also supported by a Windows-only GUI. The GUI is extremely helpful when debugging a prototype system. To establish communication between the board and the GUI, simply take the supplied USB cable and connect it to a PC. The board has an MCP2200 to handle the USB to serial communications. After launching the GUI, select the COM port and press the Connect button. If your board connects successfully, you will see it indicated in the bottom left of the GUI. By going to the Serial Debug tab, we will see the GUI supports the full debug menu options. When selecting a radio button on the GUI, the board's LCD and states will automatically update. By selecting the Receive Signal Strength Indicator, or RSSI radio button, we are able to see a scrolling graph indicating how well the signal is being received by the analog front-end chip, the MCP2035, for demodularization. I have put this mobile device into a continuous transmit to help highlight this. The touch sensor debug state also contains a scrolling graph useful when attempting to debug touch sensitivity issues. Both the RSSI and touch debug states have the ability to capture and save data into a comma-separated values, or CSV, file for evaluation. Looking at the Address Mode tab, there is more information about the board given. Listed are the valid mobile ID possibilities. There are up to 8. Also, we are able to delete a mobile device from the list. From the GUI, we are able to ping individual devices and even communicate with devices not on the valid list. Also, from here, we are able to loop back a message from the PC to the board. From the board, it couples to the body and then enters the mobile device. One more final feature included with the development board is bootloader support. So again, taking advantage of the onboard MCP2200, we are able to update the application firmware on our board from the full demonstration firmware to one of the simple example projects also included with the installation of the BodyComm development kit. Then, after completing the update, we can see that the firmware has been changed. The intended purpose of the development kit is to introduce the BodyComm technology through a simple example. The protocol method of communication between devices can easily be altered. The included demonstration firmware with the kit should serve as a good starting point and example of using the core BodyComm framework. The mobile device has been designed in a sandwich method for quick and easy separation for custom power and signal coupling point designs. For more information regarding the BodyComm development kit, please visit www.microchip.com/security. For more documentation regarding the kit, see the user's guide, demonstration board, and programming and GUI quick start guides found within the development kit's installer.